In this video I am going to explain about ideal gas and ideal gas equation. In my last video I have already told you about Boyle's law, Charles' law, Gay-Lussac's law and Avogadro's law. All these are gas laws, right? That means all these laws explain about the substances present in the gaseous state. The behavior of the substances present in the gaseous state, right? So gaseous law, ideal gas. So ideal gas means the gas which obeys a gas that follows Boyle's law, Charles' law and Avogadro's law. Strictly is called as ideal gas. Ideal gas. A gas that follows Boyle's law, Charles' law, Avogadro's law strictly is called as ideal gas. So what is Boyle's law? In Boyle's law, P is inversely proportional to volume. That means pressure is inversely proportional to the volume. In Charles' law, volume is directly proportional to temperature. In Avogadro's law, volume is directly proportional to the N. That N means number of gaseous substances present. Number of moles or molecules present. Number of moles, number of atoms or molecules of gas. N means amount of gaseous substances. Amount of gaseous substances. So a gas that obeys all these three laws, then it is called as ideal gas. In Boyle's law, pressure is inversely proportional to the volume. That means at constant temperature, right? In Charles' law, volume is directly proportional to the temperature. That means pressure is constant here. And in Avogadro's law, volume is directly proportional to the N. N means amount of gaseous substances. That means number of atoms or molecules of gas. Here pressure and temperature is constant. So a gas that follows all these laws, then it is called as ideal gas. In ideal gas, there is no intermolecular forces. Generally, in real gases, not ideal gases, in ideal gases there is no intermolecular forces, but in real gases there is intermolecular forces present. So in my last video I have already explained about intermolecular forces, right? You have to watch the video once. So in real gases intermolecular forces are present, but in ideal gases no intermolecular forces. And in ideal gas there is no definite volume. In generally in real gases having definite value. But here in ideal gases no definite volumes. So and ideal gases no intermolecular forces, no definite volumes. And in ideal gases pressure is very high. In real gases pressure is less. When comparing to the ideal gas, pressure is less. And ideal gas obeys the all three laws: Boyle's law, Charles' law and Avogadro's law. and real gases does not obeys all these laws. Does not obeys all these laws. This is the difference between the ideal gas and real gas. So in ideal gas, there is no intermolecular forces, there is no definite volumes, and pressure is very high in ideal gases. Whereas coming to the real gas, there is definite volumes, intermolecular forces are present, and pressure is less. This is big difference between the real gas and ideal gas. Next, coming into the ideal gas equation. Ideal gas equations. So, gas obeys all these laws, Boyle's, Charles and Avogadro's laws. That lies, the gas is ideal gas. So, the mathematical equation for this ideal gas is, according to Boyle's law, P is inversely proportional to volume, right? According to Charles' law, volume is directly proportional to temperature. According to Avogadro's law, volume is directly proportional to N, right? So from all this equation, we have to write V is directly proportional to Nt by P, right? Nt by P. Volume is inversely proportional, that means proportional to the Nt by P. That means we have to remove the proportional, right? So that's why we are applying constant R, Nt by P, right? Nt by P. So whereas R is called as proportionality constant, right? So PV is equal to nRT. PV is equal to nRT, right? Whereas R is called as gas constant. R is called as gas constant and its value is 8.314 joule Kelvin universe and mole universe. R is gas constant. PV is equal to nRT is ideal gas equation. You have to remember clearly, ideal gas equation is according to Boyle's law, Charles' law and Avogadro's law. So R is gas constant and its value is 8.314 joule. So, and it is also called as universal gas constant. Universal gas constant. So P1 V1 by T1 is equal to NR. I am writing in a equation in this. I am writing in this equation in another form. P1 V1 by T1 is equal to, that means T is reverse here. P1 PV by T is equal to NR, right? So P1 V1 is by T1 is equal to NR. That means initial pressure, initial volume and initial temperature, right? Then final P2 V2 by T2 is equal to NR, right? So P1 V1 by T1 is equal to P2 V2 by T2. This is known as combined gas law. This is known as combined gas law. So ideal gas equation is also called as equation of state. Equation of state. Why? Because it describes the state of gas. It describes the state of gas. That's why it is also called as, ideal gas equation is also called as equation of state. Equation of state.